part of this is also going to help you with your revision for your common test, because Pythagoras' theorem is going to be in your common test, right? And remember, part of that was knowing where the right angles exist. So it's going to remind you that when we have a rhombus, the diagonals intersect at a right angle. Yeah, yeah? It is also going to remind you that when we have an isosceles triangle, when it cuts it in half, you've got a right angle, right smack bang there. I would hope you don't have to be reminded that a rectangle has, I mean, come on. A kite, can't say that occurs too often. But anyway, the other thing that I would like us to be aware of is two words, right? Two new words with diagrams. Oh, that was a good change. As Aiden's work is still there, beautiful. And we've already come across one little phrase, and that is angle of, starts with an E, angle of, was in your task sheet. I am looking for the word elevation. Okay, so when we've got angle of elevation, that's when we might have something on the floor and it means that we're looking up. So this would be your angle of elevation here. So if the angle of elevation is 30 degrees, we would put the 30 degrees here. Agreed? The other one, and let's not take this the wrong way, but the angle of depression. And you're going to find questions like this when they're at the top of a building or top of a cliff. I know, it's just how they do it. Shh. So, if we're saying the angle of depression is 40 degrees, here's the building or the cliff, whatever, and they're looking down. Where are we? Oh, that's a bit loopy, isn't it? Make that a little bit straighter. There we go. No, it's still curvy. Oh well, you get the gist. Where would I put the 40 degrees? Yes, Micah?
Is it directly above the right angle? Like at the top of the...
Here?
Yes.
No, it is not. So that limits the other options.
The other angle.
So if we're here, you're looking down, that is your angle of depression, right? But you've then got two options. You can say, well, yeah, I could have put that 40 there, or I know that that's got to be 90 degrees, so 90 take 40 is 50. Why else, though, could you say, well, hang on, if that's the angle of depression there is 40, why does this have to be 40? Apart from that has to add up to 180, but good, yeah? That's what Aiden just said, yep.
Like the shape, just mix itself, and then you have the exact...
Okay, so well done. I love that you visualize that. So some people see that, yep, you could just turn it upside down on its head, right? So if that's 40, you could do, and so on, because you'd have this height or whatever. I guess the answer I'm looking for is when we have, parallel, someone just said the words, when we've got the parallel lines, this angle and this angle equal each other, what is that property called? It's not corresponding. Corresponding is the F, but I love your, I love the language. So if we've got corresponding, that one and that one, right? Yes, yeah, it's a poster at the back there. But alternate, okay? Or, as Lucinda Thurmer used to say, alternate. We just put the emphasis in the different spot. Bit worried some books are still shut. So we've got exercise 17E there. Today's date is the 8th. It is our last lesson before our long weekend. We'll just confirm again, how many days off are you going to have, Hamish? 4. Ask me, how many am I going to have off?
5.
5! One more than you. I know, lucky duck. Okay, here we go. So what I've got in yellow is what you need to have. So you need to have this. We've got question 1. A seesaw has a length of 52 meters. When one end is resting on the ground, it makes an angle of 23 degrees with the ground. How far is the other end above the ground? So, Harry, we draw a right angle triangle. Where are we going to stick the 5.2? Clearly, that's the length of the seesaw. And they've got, they've got the 23 degrees. Now, as you are doing this, can you make sure that you're reading the question, you're matching it with the diagram that they've given you, because what will happen is they will start easing off on the diagrams and it's just the worded questions. Okay, once you've got that, what do we then have to do?
The sides.
Not yet. How far is the other end above the ground level? So what are we actually finding? That's the angle of elevation there, but where am I sticking my X basically? On the bottom or at the, yeah. So you must actually indicate what length you are trying to find. If you don't do that and you just put an X in your calculations, well, how do I know what X you're doing and what your labels are then, right? So you've got to make sure you put your X. Okay, so now, yes, you were all excited. Do you need to label to choose the rule? Who can just look at it and they know what the rule is? It's been a while. It's been like a little time since we've done it. Does everyone agree that it's sine? Yeah, I agree. So what you would have done if you couldn't see that it was sine, here's my hypotenuse, because it's opposite the right angle. This is the angle that we're focusing on, which Amy, correct, that is your angle of elevation, and this is your opposite. I'm not even going to put A down here because there's nothing there. So well done. We write our rule. Opposite over hypotenuse. We sub our information in. And now we look and we go, do we have to look at any examples to help us solve it? As we said, hopefully we can look. We don't have to look at an example because our algebra is fantastic. How do I get X by itself?
You times both sides by 5.2.
Exactly. To get rid of the divide by 5.2, we times. So we can fancy it up with the little therefore symbol. You love the therefore symbol. X will equal 5.2 times sine 23. And before you pop that in your calculator, you just have to check, is there a little D at the top of your screen? Okay? Because if there isn't, you're going to get the wrong answer. The other thing you're checking for, X, we know, will have to be less than 5.2. Agreed? Because 5.2 is your hypotenuse. What would we get?
0.090.
Okay, so 0.090. Do you think that might be a little bit amok? Well, 0.090. So you're saying that that would be 9 centimetres above the ground. You sort of think, oh, could that be? I mean, 20 degrees, that's not that small. I think for it to be 9 centimetres above the ground, it'd be like 1 degree. That sounds sensible. 2.01? 2.03 metres. 2 decimals. Okay, this one is saying the shadow of a tree, but really that's what we did when we went outside. We didn't measure the shadow, but we measured the distance that we were standing away from it. Okay, so the shadow of a tree is 40 metres long. The angle from the end of the shadow to the top of the tree, so they could have reworded that and said the angle of elevation is 33. Once again, all we're doing here is drawing our triangle. We're going 40, we're going 33. Okay. Without even reading the question, I really hope they're asking us to find the height of the tree, but do make sure you read the question, don't just predict. So, yep, read the last bit, find the height of the tree, so we must put X there.
Is this tan rule?
Is it the tan rule is what someone just asked? Is it? Oh, you reckon it's cosine. So we've got two different rules. So that means we have to now go through the process. Let's label. So here's my right angle. That's hypotenuse. Here's the angle opposite. Here's adjacent. What one gets the heave-ho? So now you're looking at your three rules, which is the only rule that uses O and A. Tan. You write the rule. You put your information in. All right, this is becoming really straightforward. Once again, your unknown is at the top. How do I get rid of the divide by 40? Times by 40. And away you go. What did we get for this answer, sorry?
25.98.
And I'm hoping you're going, these are quite simple. So where some of you might lose some of your marks is if you're not reading the questions carefully. So it might say, put it to the nearest metre. Or it might say the answers are in metres, asked for centimetres. So just make sure you're being careful, because let's face facts. I think this is nice. I love trig. Are we liking trig, people?
Yeah.
Yeah, no? Oh, good, good, good. Well, I should also say, are you understanding it?
Yeah.
Good.
That's it.
Yeah, that's the key. Okay. Okay, so this is where we meet maths people writing worded questions. And you might have to read the questions a couple of times. All right. A driver travels 2 kilometres up a long steady incline, angled at 15 degrees to the horizontal. So I reckon we can definitely be confident that that's your 15 degrees. Do we agree?
Yes.
Horizontal, the ground. How far has the driver moved horizontally? Where am I sticking the X? At the bottom, right? This is your horizontal part here. So we're going to put the X. So now, where are you going to put the 2 kilometres? It is a little bit misleading when they say up, because some people will scan and they'll go, oh, up, and they'll put 2 here. But a driver travels 2 kilometres up along a steady incline. So would we agree that that is the 2?
Yes.
Yeah.
Also, the diagram literally shows you what comes from.
Correct. Look at the diagram. Sure. Yeah? Keeping in mind, if you stuff that up, if you put the 2 on the vertical, that will only cost you 1 mark. The rest, you'll then get the correct working for your diagram. So that's why you must put the X. All right, we label. Or do I have to label, or can you hit me the rule?
Cosine.
Cosine, well done. You've got adjacent and you've got hypotenuse. So we've got cosine equals adjacent over hypotenuse. Sub our information. Oh, once again. I was hoping that they had the unknown at the bottom. I would like the answer, thank you.
1.93 kilometres.
Beautiful. Okay, so just making sure, I'd probably say maybe the 4th one, who knows. If the unknown is at the bottom, how do we solve it?
Oh, you switch out the.
You switch. If we're trying to find an angle, how do we solve it?
To the -1.
Right, the inverse button. So sine to the, if it's sine theta equals to the -1. If you forget, that's why we're writing stuff in your book. So go back, look, and your working out should be lovely for you to be able to follow it. So now you may continue with these, or you can do your investigation. If you do your investigation now, the textbook stuff is for homework and vice versa. Understood?